Assalamu alaikum everyone and welcome to the first tutorial in ML Fall 2024. Now, in this course, we will work with a variety of supervised and unsupervised algorithms. But before building any model, you need to understand your data. Hence, I wanted to share this tutorial first to touch the surface of exploratory data analysis, or EDA for short. Now, in this video, we will cover the generation of insights from a data frame, data visualization, feature scaling, which we will cover in a while, and lastly, we'll look into encoding. The dataset I'm going to use in this video is the iris dataset, which has 4 features and 3 classes. But I would recommend that you follow the steps on a different dataset of your own choice. Let's start with the code. Here we imported the required libraries and then we loaded our CSV file into a data frame. And then we printed the first 5 rows using the head function. If I want, I can write a number over here to print the first 8 rows, for example. And we can do the same thing for tail function as well. If we print the last 8 rows of the data frame. The next function is the info function, which basically it is telling us that there are no null values in our data frame as of now, and it also tells us the data types. So there are 4 float features and 1 string feature, which is species. The next function is called describe, and it tells us about the numeric columns of our data. It tells us about the count, the mean, standard deviation, minimum values and maximum values, and the quartiles for each column. So the quartiles here, it is telling us that 25% values in sepal length are less than 5.1, and the upper quartile, which means that 75% of values are less than 6.4. So it helps us understand the skewness of our data, and we can also help identify outliers in it. And this next function is the correlation function. I have sliced out the last column, which was the label. So I'm using the first 4 columns, which are our numeric features. And this tells us the correlation between different columns. So the main diagonal is pretty much useless because it is again the same column, but we can see there is a strong correlation, strong positive correlation between petal length and petal width. And there's also a strong correlation between petal length and sepal length. And there is a weak negative correlation between petal width and sepal width. So this is also very helpful when understanding the distribution of our data. Now let's move on to visualization. Let's start by the visualization of these correlations. So we can actually use a scatter matrix like this, dot scatter matrix, which will in a minute, data frame, comma, fig. We can specify the figure size so it doesn't fill up the entire screen, and we can specify a transparency value. Alpha is equal to 0.9, and then PLT dot show. Okay, sorry. So it is just allowing us to visualize these values over here. We saw that there was strong correlation between petal length and petal width. So here's petal length and here's petal width. So we can see it's a strong correlation. There is a strong correlation between sepal length and petal length. So the value is sepal length and petal length is 0.87. And there is a weaker correlation between sepal width and sepal length. Sepal width and sepal length is 0.1, so it's a very weak correlation, negative correlation. So the line would be something like this. And now moving on to the next visualization, Actually, let's write a function that will help us visualize each column. So let's write a function for that. Def visualize. It takes a data frame and the kind of the plot we want. Let's set it to be histogram by default. We will make a figure of fixed size is equal to a double of 12 and 4. Now we'll iterate over columns and we will plot each column, a histogram for each column, index and value in enumerate df dot columns. I want to slice out the labels column because we won't be able to identify much from it from for now. So I'm going to slice that out. Now we will plot the subplot for each column. We'll make a grid of 1 row and 4 columns, and the current active subplot would be the one at index plus 1, because index is starting from 0, but the subplots will start from 1, 2, 3, and 4, so we need the plus 1. Now for that column we plot kind. This is kind parameter which will pass the kind of plot we are passing through here. If you go over here, we'll add a title as well, plt.title val, and plt.ylabel. Let's say its length in centimeters. I think millimeters is better. Maybe centimeters better. Yeah. And we'll do a plt.title layout so they don't overlap with each other and are neatly arranged. And finally, the plt.show. I think I made a typo over here. Everything's fine. I think so, yes. Now let's plot histograms for call this function visualize data frame and kind is equal to, let's draw a histogram. From what we can see here, the standard deviation of sepal width is pretty small, and because we can see that the mean is somewhere here. Let's take a look at the sepal width in our describe function. So sepal width has a pretty small standard deviation. So it means that most of our data is clustered around the mean value, which is 3. So we can understand the distribution and the spread of the data using this visualization. Let's try another one like a box plot. So this is also a good way to identify your outliers, your median, and the skewness of your data. Now I am going to visualize our label column, which was the species column. So let's draw a pie chart for that. So df dot species dot value counts. This will print the value counts for our class labels. So we can see there are 50 labels for each class, but we can plot these with a pie chart or a bar graph. I'm going to use a pie chart over here. So kind is equal to pi. Okay, it has to be in string form. Kind is equal to pi, and we can specify a starting angle as well. Start angle, which is the initial angle of our pie chart from where it will start, and we can specify figure size. I'll call it 6 by 6. Mm, let's plot it. And now let's also plot key plt.legend. Let's paste it at upper right. Now plt.show, plt.show. Okay, so we missed the equal sign again. What? Okay, string has to close. There we go. क्या भाई? अच्छा, kindly specify. I missed the equal over here as well. So here's our pie chart, but you can see it does not look very nice. So let's improve how it looks like. We can start with our percentage symbols. Let's display it like display it in one decimal place. Here we go. We forgot a comma. Now we have the percentage, but there is no percentage symbol, so let's add the symbol as well. If I type the percentage symbol twice, it will tell the interpreter to add the percentage symbol. It looks better, but the colors, I still don't like these colors. So let's change the color map. We can use there are different color maps. I like this one, set 3. Again, forward the comma. Having all these look pretty much better, more relaxing colors. Now, what if you want to emphasize on a certain slice? We can do that with the help of the explode parameter. Explode is equal to, let's say we want to emphasize on one slice, the first slice, which is the blue one, 0.1 and 0.0, comma 0.0. Let's see what it does now. Again, for the comma. So what it does is it moves one slice away. It looks too much, so let's reduce it to 0.1. Now it's better. We can do the same thing with other slices as well. Let's do 0.2 on the third one, and here we go. We're going to reduce it to 0.1. Okay, better. So these are just one of the many ways you can visualize your data. Now in coding, let's take a look at our data frame again. We can see that the species column is still in string format, but to run a model on it, we need to encode it. Now, if we are working on a multi-class classification problem, our encoding should be one hot encoding. So let's do that. We are going to write this code. Now, the function we are using is pd.getDummies. It takes your data frame and the column you want to one hot encode. In that, our last column has been classes have been one hot encoded.